Hello everyone. In this lesson we want to talk about the chemical equation. We have studied what is the chemical reaction and what is the chemical formula. Now we want to know what is the chemical equation. To know what is the meaning the first, because we're talking about what is chemical equation, we want to know first what is the definition of chemical equation. Is an expression that uses symbols to show the relationship between the starting substances and the substances that are produced by a chemical reaction. Now we want to know how, and we want to learn how to write this chemical equation. Actually, let's start. For example, if you look at this one here, just hold on. To understand what is the chemical equation, we want to know what are the starting materials and what are the products. I'll give you like here example. If you have you want to make a sandwich, you starting with the reactants here to make a sandwiches, right? If you have like this toast and this cheese, here to make this reaction, to model this first, or to make like a sandwich, like example how to understand the chemical equation, let's do this sandwich. This sandwich they have mentioned here, it needs 2 toasts, okay, and it needs 1 cheese to make 1 sandwich. Let's see, I'm going to add here, as you see, I'm going to add 2 toast, 1, 2, and then I'm going to use 1 cheese as they asked me to make the product. Here the starting material, as you see, what is the starting material? 2 toast with 1 cheese. So these are, we call the starting material, which is what? The reactant. If I want to define what is the meaning of a reactant, are the substances that participate in a chemical reaction. Their chemical formulas are here to start the chemical reaction. Here I'm giving you like example model. I'm not talking about molecules yet. We will take examples about molecules. Okay, now what about the product? If you look at the after, you have to put this R plus between them, you have to put, and you add the toast plus the cheese, they will give what? The product, and you have to put like this arrow, as you see, this arrow, okay, that makes what? 1 sandwich. As you see, this sandwich, it contains these 2 toast with what? With 1 cheese. So this one here, what do we have here? Which is the product. What are the products? Are the substance formed in a reaction, okay? Are the substance are formed in a reaction, as you see here, okay? So let's continue now. To understand this, you have to put in your mind, when I'm doing a chemical reaction, this chemical reaction, what you use in the reactant is what? The same as what you got in the product, which means I used here like 2 toasts, as you see, okay? I found in the product also 2 toasts, right? Bread. Here I used only 1 cheese. Also, I found it's only 1 cheese, but as you see here, new bonds are formed between them, so they produced a new product with a new properties. But you have to put in your mind, what you use in the reactant, you find in the product. Okay, they have different properties, but they are the same. Yani, for example, you don't put here 2 toast and you find like 3 toast in the product, or you put 1, you find only, for example, you find 2 in the product. It should be the same number. This is the conservation of mass. You have to know the conservation of mass. The mass, that the things that you use in the reactants, they have the same mass when you have in the product. The same type of in the reactants you use, you will find them where in the products also. Let's discuss this by using not the sandwich and or I'll give you another one. If I have meat and cheese, I want to make another reaction. I want to use 2 toast bread like this, and I'll use, they asked me to use 1 meat, and here they asked me to use 1 cheese. Okay, so here these are the products, as you see, these are the products, okay. Then the reactants, sorry, these are the reactants. Okay, what you have in the product after the arrow, okay, the reactants before the arrow, the products after the arrow. What you have after the after this reaction, you have 2 bread toast, and you have 1 meat, and you have 1 cheese. Okay, so here for this as example as sandwich. What about if I have molecules now? I have now molecules. I'm talking about chemistry. I'm talking about elements. I'm talking about atoms. For example, I want to make water. They asked me here to make what? Water. They told me to make water. The reactants, you need what? You need hydrogen, and you need what? Oxygen. Forget about numbers now. These numbers in front of each element, we will talk about it later. But now I want you to focus here on the main points. The main points that I want you to focus on. What did I use here in for hydrogen? I used hydrogen and oxygen, and these are called what? Reactants. Actually, they asked me, you know, this is the subscript, how many hydrogen atoms. They asked me to use 2 atoms, and you have 2 here. We will talk about it, which is coefficient. We will talk about it later. 2 times 2, how many hydrogen molecules we have? We have like 2 hydrogen molecules, and each one and how many atoms they are for. Let's look here. Let's do it here. Just hold on. I'm going to use first 2 molecules of hydrogen. As you see here, 2 molecules of hydrogen, which means you have 1, 2, 3, 4 hydrogen atoms. What else? What do I need? I need only 1 oxygen molecule, and as you know, molecule O2, which means oxygen with oxygen. I'm going to use here 1 oxygen molecule. Hala, they will make a chemical reaction. They will rearrange. They will make a new bonds between them. So here, this is the reaction here. Okay, these are the starting materials. These are the reactants, hydrogen and oxygen. After the arrow, I found like 2 molecules of water. These 2 molecules of water, they have H2O. So as you see here, how many molecules of water? H2O. They are 2 molecules of water. How many hydrogen molecules I used? I used 2 hydrogen molecules, but number of atoms, because this 2 with 2, we only have 1, 2, 3, 4 molecules. How many 4 atoms? And here 1 molecule of oxygen. I have 2 oxygen atoms, as you see here. So here, this is the chemical equation to make what? This is the chemical equation that we used what? To make water. And from this chemical equation, as you see, we started with the reactants, hydrogen and oxygen, the symbol of hydrogen, which is H, the symbol of oxygen, which is O, and these reactants, they combine together. They have a plus sign between them, as you see, and this is the arrow. The arrow before the arrow. Before the arrow here, we have what? We have the reactants, and after the arrow, we have the product. The product, which is what? Which is water, as you see. As you see here, for the same, I used hydrogen in the reactants. I found hydrogen in the product, right? I used oxygen in the reactants. I found oxygen in the product. I used 4 hydrogen atoms of hydrogen in the reactants. In the reactants, I found how many hydrogen? Like, count them: 1, 2, 3, 4 hydrogen atoms. I used 2 oxygen atoms in the reactants. I found them also 2 oxygen atoms. So the same types of atom that you use in the reactant, you will find them in the product. The same number for the reactants of each reactant, you will find it in the product. But what happened during the chemical reaction? They only rearrange, and they make new bonds between them. You have to put this in your mind. This is how the chemical equation happened. This is the conservation of mass law. What the mass cannot be destroyed or created. Okay, so let's make another equation. Let's model another equation here. For this one here, before the reaction, the reactants, I want to make ammonia, which is NH3. What do I need to make ammonia? I need only one molecule of nitrogen in two, yani nitrogen with nitrogen. So here I'm going to use only one. So here look at the blue spheres represent the nitrogen. 1, 2. Okay, then plus what do I need? Three molecules of hydrogen. So you have to look at this number here. Okay, represent how many molecules of hydrogen? 3. This one, number 1 here, represent how many molecules of nitrogen? Only 1. Okay, but what about number of atoms of nitrogen? 2. What about number of atoms of hydrogen? 3 times 2, which means 6 hydrogen atoms. Let's see. I'm going to use how many molecules? 1, 2, 3, as they asked me. Okay, now what about the products? The products that I have 2 molecules of NH3. As you see here, this is the first molecule, molecule number 1, and molecule number 2. Okay, so here as you see you have 2 hydrogen atoms because I used only 2, and I used 6 hydrogen atoms in the reactant, so I'll find in the product what 6 hydrogen atoms also. Okay, so here for what you used is the same. The reactants that you will find in the products, but they only what they rearrange and make, and they form a new product with a new bond. Okay, let's continue now. I'll give you another example. The other example here, I want to make CH4 plus O2. Here I want to burn methane. Here CH4, which is methane. I want to burn methane by using oxygen. I want to react methane with what? With oxygen. I want to make a burning combustion reaction, or which is what the burning reaction. Here what they asked me to use how many molecules of CH4? They asked me to use only 1. So this is 1. Okay, and they asked me to use how many molecules of oxygen? They are 2. So 1, 2. Look at the product. After the reaction, I'll find 1 carbon dioxide molecule and 2 water molecules. Look again. Here in the reactants, this chemical equation, this is the chemical equation. These are the reactants, right? And these are the products. And as you see, I use CH4. I use carbon. C represents carbon. H represents hydrogen. Here, this molecule CH4, it has only 1 carbon molecule. It combined with 4 hydrogen molecules, as you see here, 1, 2, 3, 4. Okay, plus O2, 2 molecules of oxygen. I'll find in the product how many hydrogen? 1, 2, 3, 4, the same number as I used in the reactant. And I found here also for nitrogen, sorry, for carbon, I have only 1 in the reactant, so I have only 1 in the product. For the oxygen, as you see here, I used 4 oxygen atoms. Also in the product I have 4 oxygen atoms. You can count them. Look at this is O2. We have 2 oxygen atoms, and here I have this 2 times this oxygen. It means we have 2 oxygen atoms also. So as you see, what I use in the reactants, the same, and the product, the same number. This is the law of conservation of mass. You can't find numbers are different in the chemical equation. So this one is very important. I'm going to give you another example. Let's look at this example. You have this equation, carbon plus carbon, okay, plus oxygen. That will give carbon dioxide. Carbon, which is C, this chemical formula, the chemical symbol to make the chemical equation. The C is the carbon plus oxygen. Always you can find the oxygen as 2 molecules together, O2. Okay. That will give, these will combine together. Oxygen, as you know, 1 oxygen bonded with another oxygen. This bond between oxygen, it will break and form a new bond to combine with carbon. So it will give what? Carbon, CO2. They will combine to give. So these are the reactants, and these are the reactants, and these are the products. And as you see, I used only 1 carbon in the reactant. I found in the product 1 carbon. I used 2 oxygen in the reactant, I found also 2 oxygen atoms in the product. So here the law of conservation of mass is very important. You have to know the law of conservation of mass. You're talking about the type of atoms, number of atoms should be the same in the reactants and the products, and the number of atoms of each element should be the same in the products and the reactants. And you have to know here the type and the number and the mass the same. Okay, so here this is very important to know about what the chemical equation and how to write the chemical equation. Here, as you see in the reaction I involved, we have a number mentioned about the number. So here this is all about the chemical equation, how to write it in general. If you have any question about how to write the chemical equation, you can send me your question. Thank you for listening.